Chapter 8, Data Analysis, Inferential Statistics. We spoke about descriptive statistics, which use the data to provide description of the population either through numerical calculations or graphs or tables. Class of descriptive statistics include the mean, the min, the max, the standard deviation, the median, the skew, and the kurtosis. Inferential statistics are designed to determine the probability that the hypothesis accurately represents the conditions of the population. They make inferences and predictions about a population based on a sample of data taken from the population in question. They're a function of the sample data that assists you to draw an inference regarding an hypothesis about a population parameter. For example, the difference was statistically significant, means that the probability of error was acceptably low, for example, a p-value of 0.02, or an error 2 out of 100 in rejecting the null hypothesis. Inferential statistics are tools that help researchers test their findings to establish how representative these findings are. In a sense, one might think of inferential statistics as a tool for bridging the gap between the actual observation of the research participants to the hypothetical observations of the population they represent. For instance, we use inferential statistics to try to infer from the sample data what the population might think, or we use inferential statistics to make judgments on the probability that an observed difference between groups is a dependable one or one that might have happened by chance in this study. Measures of association, relationship between two or more variables. We use correlation coefficients, the Pearson's product moment correlation coefficient, or the Spearman rank order correlation coefficient, often for an ordinal variable, for example, the rank of a GPA or severity levels. It is a non-parametric statistic and helpful to use when the assumptions for the Pearson's R are not met. What is a correlation? It is a way of measuring the extent to which two variables are related. It measures the pattern of responses across the variables. Some examples. Is the speed of word identification related to the number of letters in the word contains? What is the relationship between the amount of time spent studying and the grade on the exam? Does level of education predict the amount of income? The relation between two variables. Two measures per case in an individual situation, x and y. The direction of association, linear. Positive, x is high and y is high. X is low and y is low. Negative, x high, y low. X low, y high, or none. Everything just scattered. A scatter plot, each individual xy pair is plotted on a 2D graph. For the Pearson's product moment correlation, both of the variables must be measured on an interval or ratio scale, aka continuous variables. For example, the hours of studied and the exam scores. This is a very small relationship. It's the appreciation of the Norwegian black metal band Dimmu Borgir against age. You can see the line that shows a very small relationship. Here is a positive relationship. Notice as x increases, y increases. The scatter plot shows a negative relationship. Here's a full range of R. 0.1 to 0.3 is a small correlation. 0.3 to 0.5 is a medium relationship, and larger than 0.5 you have a very strong relationship. Either in the positive, be a positive 1, positive correlation, or a negative 1, perfect negative correlation. Things to know about correlations. They range from -1 to +1. -1 is a perfect negative correlation, 0 is no correlation, and +1 is a perfect positive correlation. Sometimes the sign is arbitrary. Study time correlated with the number of items correct on a 100-item test. Positive. Study time correlated with the number of items missed on a 100-item test. Negative. Absolute y values show strength of association between x and y. Things to know about the correlation. It is an effect size. Plus or minus 0.1 is a small effect. Plus or minus 0.3 is a medium effect. Plus or minus 0.5 is a large effect. The coefficient of determination, r squared. By squaring the value of r, you get the proportion of variance in one variable shared by the other.